These suits could weigh over 200 pounds, and divers didn't swim in them. They walked, step by step, on the bottom, often with little to no visibility, no freedom of movement, and their only connection to the surface was a single line. So how did this even work? How do you move, operate, or survive in something this heavy? To answer that, we need to look at the system that defined diving for decades, the Mark V. Before you can understand the suit, you need to understand what it was up against. The first problem is pressure. Water gets heavier the deeper you go. Every 10 meters adds another atmosphere. At 30 meters, your body is already under 4 times the pressure you feel on the surface. Then there's buoyancy. Your body wants to float, which is a problem if your job is to stay on the bottom and actually work, and not just work. Move objects, lift them, secure them, because every movement, every breath makes you slightly more buoyant. You're constantly fighting to stay down, while trying to stay stable enough to do the job. Add cold water that drains heat from your body, currents that push you off position, and suddenly, even the simplest task becomes difficult. This isn't just an uncomfortable environment, it's a hostile one. Every single one of these factors works against the diver, and the suit had to fight all of them at once. At the center of the entire system was the helmet, not just protection, but a sealed life support system. It was made from heavy metal, usually bronze or brass, with thick glass ports to see through. The helmet itself could weigh around 35 to 40 pounds. And it didn't just sit on the diver's head, it was bolted and sealed to a chest piece, the breastplate, using threads, bolts, and gaskets to make it completely watertight. Once it was closed, the diver was locked inside. Air was pumped down from the surface through a hose. Inside the helmet, the diver could slightly control the internal pressure and airflow. But the air had to go somewhere. You couldn't just breathe out into the water, so every helmet had an exhaust valve. As the diver exhaled, excess air was pushed out through that valve, keeping pressure stable inside the system. The suit itself was not built to resist pressure. It was made from rubberized canvas, a flexible shell designed to hold an airspace around the diver's body. Air filled the entire suit, the legs, the arms, the torso. And that created a problem, because air always rises. If too much of it shifted into the legs, it could flip the diver upside down, a situation that was extremely dangerous and difficult to recover from. To counter that, divers were heavily weighted. Lead plates were strapped to the chest and back, often around 40 pounds each, to keep the body stable and upright. And on the feet, massive cast iron boots, flat, heavy, and wide, designed to give the diver a stable platform to walk on the bottom. Altogether, the full gear could weigh over 200 pounds, which is exactly what made walking, not swimming, possible. The diver was just the tip of a much larger system. Most of it stayed above water. Air had to be pumped down through a hose. At first, that meant 2 sailors on a hand pump, turning the handles constantly, hour after hour. Later, mechanical pumps took over, making the air supply more steady. But the principle was the same. The hose itself was a lifeline. Cut it, kink it, or block it, and the diver could quickly run out of air. Early on, communication relied on pre-arranged signals, tugs on the lifeline. Later, divers could talk to the surface through wired communication systems, but the signals never disappeared.
Как самочувствие, Юра? Разворачивай через правое плечо.
The Soviet 3-bolt diving system looked very different, but the idea was the same. Keep the diver alive in a hostile environment. Early designs were influenced by German technology, but Soviet engineers added their own solutions. Unlike the Mark V's 12 bolts, the 3-bolt system was faster to suit up, but offered less fine control over the seal. Some things were better, simpler, quicker, easier to maintain. Some things were worse, less adjustability, more risk if a bolt failed. These suits were used by military divers in submarine rescues and at ports across the USSR. But none of that mattered if you were the one inside. Getting into the Mark V wasn't quick. It took 15 to 20 minutes and always required assistance. Every bolt, every gasket had to be perfect. Once submerged, the world disappeared. Darkness all around. Pressure building in your ears as you descend. The only sounds, the hiss of your air and your own breathing. Moving on the bottom was deliberate. Lean forward slightly, arms out for balance, eyes down. One wrong move and you could tip, trip, or tangle your lifeline. The most dangerous moments were sudden, a suit squeeze if the air supply failed, a kinked or severed hose cutting off your air, or a lifeline caught on debris. Most work happened between 20 and 40 meters, in rare cases, down to 90. Inside that helmet, it was just you, the sound of your own breathing, and the bottom. In 1943, everything changed. Jacques Cousteau and Émile Gagnon invented the aqualung and gave divers freedom. No hose, no surface team, just you and your air. But that freedom came at a cost. Heavy diving systems still did things scuba couldn't. Stable work on the bottom, lifting heavy objects, staying down for long periods. That's why they never fully disappeared. Variations of these systems are still used today, especially in commercial and military diving. And modern helmets like Kirby Morgan may look different, but the core idea remains the same. Keep the divers supplied, stable, and alive. 200 pounds of metal and rubber, a hose, a rope, and a team above. That was enough to put a human being on the bottom and trust the system to bring them back.